All right, more functional groups, aldehydes and ketones, some pretty interesting chemicals and functional groups we're going to talk about today. They have great similarities, as you're going to see. So what exactly is an aldehyde or a ketone? How we make these things is we're going to switch out a couple hydrogen atoms on the carbon chain for a carbon to oxygen double bond. So we have to lose a hydrogen atom when we're doing this. And how you have an aldehyde, you have this carbon to oxygen double bond is going to be at the end of the chain of hydrocarbons. So here is an example here. I've got a 3-carbon chain, and you can see that the carbon to oxygen double bond is on one of the end carbons. That is an aldehyde. A ketone is got the carbon to double bond oxygen in the middle portion of the chain. So here's an example of a ketone. So again, very similar structures in the sense of you can have isomers of these who have the same chemical formulas, but the aldehydes have the oxygen double bond on the end of the carbon chain, where ketones have the carbon oxygen double bond in the middle portion of the chain. So here are some examples. I want you to pause the video right now, and it's a mixture of aldehydes and ketones. Decide which one of these is an aldehyde and which one is a ketone. Okay, pause the video now. Okay, hopefully you're back. The first example here, you don't have a multi-carbon chain, so you might have chosen ketone, but in fact, this is an aldehyde. This is the smallest aldehyde you can have. The more common name for this is formaldehyde. It's a pretty toxic substance that was in the insulation of some homes. The next one going across left to right is a ketone. Again, you got that carbon double oxygen bond in the middle. The next one is an aldehyde. This next one is a ketone. You got the carbon double bond to oxygen in the middle. And then the last one, obviously the carbon to oxygen double bond is on the end, so that is an aldehyde. So how do we actually name these things? Let's start off with aldehydes, okay? Aldehydes, they end in Al. All of our other naming rules still apply, so we're still looking for how many carbons are in the longest chain, and if it's a double, single, or triple bond, and then finally we ended off with Al. So in the first example here, we have 1 carbon, so there's meth. It's all single bonds between the carbons because there's only 1 carbon, so it's and then it ends in Al. So this is methanal, okay, methanal. Again, this has a common name called formaldehyde. In the next one, you have to count the carbon chain, 1, 2, 3, 4, 5, 6. So there's 6 carbons. All the carbons are combined in single bonds, so it's an an, and then it's an aldehyde, so it ends in Al. So 6 carbons is hex, and al. Okay, pretty straightforward stuff for aldehydes. Again, because the aldehydes, the carbon oxygen double bond is always on the end, you don't need any numbers or anything in the formulas or the names. For ketones, we have an ending of ONE. So notice, it's all in the names of these things. Ketones have ONE in them. All of them end in ONE. So we look at the carbon chain. So this first one, we've got 4 carbons in the chain. That's bute. All the carbons are combined in single bonds, so that's and then it ends in ONE. So this is butanone. The next one, carbon chain is 3 carbons long, so there's prop, single bonds between the carbons, and then we've got that one for the ketone. So this is propanone. Now, propanone is actually kind of interesting. It has a common name too, sometimes called acetone. You might have this in your home. This is nail polish remover. Okay, so you might actually have a ketone in your house. If you have nail polish remover, acetone in your house, you've got a ketone in your house. As soon as we start getting above butanone, once we get into pentanone and above, we start having structural isomerism. So pentanone has 2 possible structures. Here they are here. Now we use our similar naming styles with adding a number in front to say what carbon the carbon double bond to oxygen is at. So in this, both of these are 5 carbons long, so all of these are pentanones. But in this first example, the carbon right here, this is carbon 1, 2, 3. So this is 3 pentanone. This one here, we number this carbon 1, 2, so this is 2 pentanone. Okay, these are the only other options. If I put this carbon oxygen double bond up over here, we'd still have 2 pentanone, because we have to remember you always have to communicate the functional group using the lowest possible number. Okay, let's talk about the properties of aldehydes and ketones now. So they all have lower boiling points than alcohols of similar sizes. They're less soluble in water than alcohols because they don't form some of those hydrogen bonds that we've chatted about previously. They're more soluble in water than hydrocarbons because of the unequal sharing of electrons in that carbon to oxygen double bond. That's a polar covalent bond, which gives a little polarity. So therefore, since water is polar, these things are slightly more soluble in water than just a straight chain hydrocarbon like butane or something like that. They can mix with both polar and non-polar substances, so they make great solvents. If you go on in chemistry, you're going to use acetone quite a bit. That propanone is used to clean glassware, and it works fantastic. And those of you who ever put nail polish on, it just takes that substance, that nail polish right off. Okay, let's continue on our chat with functional groups and do our last kind of big functional group, carboxylic acid. These are pretty important things in our body, and they've got many applications, as you're going to see further on when we start talking about reactions of carboxylic acids. So what the heck is a carboxylic acid? Well, it contains a carbon that's double bonded to an oxygen, and that carbon is also singly bonded to what we've been calling an alcohol group, a hydroxyl group. So a single bonded to an oxygen that's also single bonded to another hydrogen. So common carboxylic acids, vinegar is a big one. So vinegar is called ethanoic acid is its other name, and it's a 5% volume-to-volume solution, and it's a carboxylic acid. Soured wine, again, when you go to a restaurant, sometimes the waiter or waitress will give you a sample of a bottle of wine if your parents have ordered it. Why you're doing that is you're tasting to see whether the wine has soured or not. If it has soured, that means that unwanted bacteria have gotten into the bottle of wine, and unwanted bacteria sometimes make vinegar. So this is one way we actually make vinegar, is they just sour. It's this process of souring wine, very similar. Soured milk or yogurt, if you've made milk or yogurt, is soured by lactic acid, which is also called hydroxyethanoic acid. It's kind of a mouthful. So here's the two structures. So there's vinegar here. Again, here's the carboxylic acid group right on the end. So it's a carbon double bonded to an O. It's kind of like a ketone or an aldehyde. But then this carbon here, instead of being bonded to just a hydrogen or another carbon, it's bonded to this hydroxyl group, this OH group there. So this is vinegar, ethanoic acid. Notice eth means two and single bond. So two carbons in the chain, single bond between the carbon. And then we got this oic acid group, this carboxylic acid group. Lactic acid, something that your body produces. This is why your muscles hurt after a workout. Here is the carboxylic acid group here. Again, you've got this C bonded to O, and it's also bonded to the OH group. So lactic acid is there. So how we actually name carboxylic acids is pretty straightforward. We count the number of carbons and place oic acid on the end. So here, 1, 2, 3, 4, 5. We've got pent, obviously. So the thinking here is, okay, what's the longest carbon chain? In this case, it's 5 carbons, so we have pent. Are they single, double, or triple bonds? All the carbons are single bonds, so we've got ane. And what is our functional group? It's a carboxylic acid, so it ends in oic acid. We put all this together. This is pentanoic acid. Okay, pretty straightforward stuff. I want you just to pause the video. I want you to just test yourself out. Can you draw propanoic acid? Again, how many carbons in the longest chain? Single, double, or triple bonds? And then what is that oic acid group? Okay, pause the video now. All right, we're back. Hopefully you've got this structure here. Again, 3 carbons long, single bonds between all the carbons, and this carboxylic acid group there. Carboxylic acids are used in a whole bunch of things, but the properties of them, they have all the same properties of acid. They taste sour, have a pH below 7, litmus paper goes red, phenolphthalein becomes colorless, bromothymol blue goes yellow. Again, all common acid-base indicators from grade 10 science. The OH groups makes them polar and soluble in water if the non-polar end's not too long. So smaller chain carboxylic acids are more soluble in water than longer chain carboxylic acids. They've got higher melting points because of the hydrobonding that the hydrocarbons can have of the same molecular size. Again, just higher melting points is something to think about. Okay, we're going to end our chat at there. There was aldehydes, ketones, and carboxylic acids. All of them kind of have similarities of that carbon to oxygen double bond. All right, thanks.